The next example is trace y square into bracket a plus x is equal to x square into bracket a minus x. Now if we observe this equation as far as symmetry is concerned, this equation does not contain even power of x everywhere, because in this term power is odd. Here power is even, but when I multiply this x square inside the bracket, then power will be odd. But this equation contains power of y, it is even, and therefore this curve is symmetric about x-axis. So the first point, symmetry. Given curve is symmetric about x-axis. Okay. Now the second point, it is origin. Now to check whether the passes through origin, put x is equal to 0, y is equal to 0 in the given equation. When x is 0, y is 0, LHS is 0, RHS is 0, and therefore equation gets satisfied, and therefore the passes through origin. So origin is present on the curve. Now to get equation of tangent at origin, equate the lowest degree term to 0. So which is the lowest degree term? Here a into y square, degree is 2, degree is 3. Here degree is 2, degree is 3. So there are two terms having least degree. Therefore, put them equal to 0. So a y square minus ax square equal to 0, and this implies y square minus x square is equal to 0, and therefore y is equal to plus or minus x. What it means? Y is equal to x and y is equal to minus x are two tangents at origin, and therefore origin is called double point. But these two tangents are really distinct, and therefore origin is unknown. So origin is unknown. Okay. Now the next point is points other than origin. Points other than origin. Now to get points other than origin, as this equation or this curve is symmetric about x-axis, and therefore what we do, we find the point of intersection on both the axes. To get point on x-axis, put y equal to 0. So when y is 0, what we will get? X square into a minus x is equal to 0. This implies x square 0, a minus x equal to 0 implies x 0 and x is equal to a. Now for y0 we get x0, that is origin, but already we have calculated equation of tangent at origin. Now points other than origin is y0 and x is a, therefore a0 is the point other than origin. Now what we will do, to get point on y-axis, put x is equal to 0, and when x is 0, right hand side is 0, this is 0, so ay square is equal to 0, and when ay square is equal to 0, this implies y0. It means origin is the only point with y-axis. So the points other than origin are only one point, that is a comma 0 is the point other than origin. Okay. Now to calculate tangent at a comma 0, what we will do? We will use the method of calculation of derivative. Now I will write your equation, that is y square is equal to x square into bracket a minus x divided by a plus x. Now if I differentiate this equation with respect to x, what I will get? 2y divided by dx is equal to d by dx of this bracket, it is x square into a minus x divided by a plus x. But after differentiation of this bracket with respect to x, whatever terms we get, all terms containing either constant or function of x, and therefore dy by dx is equal to 1 by 2y into d by dx of this bracket x square into a minus x divided by a plus x. But the value of dy by dx at the point a comma 0, if I substitute here, then what we will get? When x is a, this numerator will be 0, and when y is 0, this denominator is 0. But after performing this differentiation and after applying L'Hospital rule, we will get the value of dy by dx, it is infinity. But if dy by dx is infinity, it means tangent is parallel to y-axis at the point a comma 0. Okay. Now the next point is to get asymptotes. Okay. So now we will move further. To get asymptotes, what we do? So the next point is asymptote. To get asymptote parallel to x-axis, equate coefficient of highest power of x to 0. Now here from the given equation, I will write the equation y square into a plus x is equal to x square into a minus x. Now here if I multiply x square inside this bracket, then highest power will be 3, but its coefficient is minus 1, and therefore as coefficient of highest power of x is constant, asymptote parallel to x-axis is absent. Similarly, to get asymptote parallel to y-axis, find highest power of y, that is y square, but its coefficient is a plus x. So put this coefficient equal to 0. So a plus x is equal to 0. This implies x is equal to minus a. So x is equal to minus a is an asymptote parallel to y-axis. Okay. Now the next point is region of absence. Region of absence. To calculate region of absence, whether curve is present in a particular partition, first we draw x-axis and y-axis. Now here what are the steps? Plot the points of intersection first. If asymptote is present, then asymptote itself is one of the partition. Define the partition and check whether curve present in each partition. Now first we will plot the points of intersection, and here points of intersections are origin and one more point, that is a comma 0. Okay. If asymptote is present, then asymptote itself is one of the partition. Yes, here asymptote is present, that is x is equal to minus a. I will draw that x is equal to minus a as one of the partition. Now I will draw the partition through these 2 points of intersection. Already I have drawn y-axis, so I will draw one more line which passes through the point a comma 0. Now how many partitions we have? It is first, this is second, this is third, and this is fourth. Okay. Now we are going to define these partitions. How to define these partitions? The first partition is, as this line asymptote, it is x is equal to minus a, it means this point is minus a 0, this is 0 comma 0. So this partition is x less than minus a, minus a less than x less than 0, 0 less than x less than a, and here x greater than a. Okay. Now we will check whether curve present in each partition. So choose x is equal to minus 2a. Now what is y square? So here I will write the formula. Y square is equal to x square into bracket a minus x divided by a plus x. Okay. Now when x is minus 2a, a minus of minus 2a, this is positive, but this is negative, and therefore y square is negative, curve is absent. Here I will choose value of x is minus a by 2. When value of x is minus a by 2, this is positive. This is positive. Here a minus a by 2, that is half a. This is positive, and therefore y square is positive. Curve is present. Here I will choose value of x is a by 2. When value of x is a by 2, positive. This is positive. This is positive. So y square greater than 0. Curve is present. And here I will choose value of x is 2a. When x is 2a, this is negative, this is positive, this is positive. So y square is negative, and therefore curve is absent in fourth partition. So overall curve is present in second and third partition. Now the last part, that is shape of the curve. So I will draw the shape of the curve. First, draw the coordinate axis. Okay. Now, first point symmetry you will see at the last. The second is origin. Yes, origin is present. At origin, what are the tangents? Y equal to x. This is the line y equal to x. Y equal to minus x. This is the line y equal to minus x. Now points other than origin, there is only one point, that is A0. So I will draw that point here, A0. At this point, tangent is parallel to y-axis. I will draw the tangent at this point. Okay. If this line is tangent at this point, it means probable curve. It is either on this side or it will be on this side. But after a comma 0, curve is absent. After a comma 0, curve is absent, and therefore this part of the curve we will have to remove. So we will remove that part. Now next is one asymptote is present, and that asymptote is x is equal to minus a. That asymptote is x is equal to minus a. So suppose this line is x is equal to minus a. If this line is asymptote, then total 4 probable curves. One is on this side, second is on this side. Here also, either on this side and again on this side. But before minus a, curve is absent, and therefore we are going to remove these two parts. So here also I can remove. Okay. Now this line is tangent. So this is the possible curve, and again on this side also. This line is tangent. This is the possible curve, and again on this line also. Now the part of curve lies on this side. So I will extend these two curves, and here also I will extend this curve. Now here on this side there is no curve, but this part of the curve and this part of the curve will have to extend, because here this line is acting as asymptote, and therefore I will draw the asymptote like this. Okay. Similarly on this side also. So here I can join these two parts of the curve. Now as there is no part of the curve on this side, I will remove this. Again similarly I will remove this. At the same time I will remove this. And again this also I can remove. So this line, it is asymptote. So here I will write asymptote. So this line is tangent at a comma 0, and this is final part of the curve. This is final shape of the curve. Actually, I have extended these two parts here on this side and again on this side. But these two parts I have not extended because part of the curve does not lies in different